Welcome to the Golden Mathematician YouTube channel, where mathematics is simplified and broken down to the tiniest pieces, just so you can understand and develop love for mathematics. Get ready with me to unlock the world of numbers, equations, and problem solving. Whether you're just a math lover, student, or someone who is just curious and wants to know more about the beauty of mathematics, you are in the right place. Don't forget to subscribe and hit the notification bell icon so you never miss out on new videos. So without further ado, let's explore, learn, and conquer mathematics. Euclidean algorithm is simply a way by which the greatest common divisor of two integers is found. No matter how big the two integers are, we can find their greatest common divisor using the Euclidean algorithm. It simply involves us repeatedly performing long divisions, and then the last remainder, which is greater than 0, is our greatest common divisor. But wait a minute, why are we looking for the greatest common divisor? Or what is a greatest common divisor? A greatest common divisor, popularly known as GCD, of two integers is simply the greatest number which can divide both integers evenly. I come again. A greatest common divisor of two integers, as the name implies, is the greatest number which can divide both integers evenly. Let's solve an example of finding the greatest common divisor of two numbers using Euclidean algorithm. Using Euclidean algorithm, find the greatest common divisor of 10 and 45. Now, the first thing you have to do is to find out which is your A and which is your B. Now, the A is usually the biggest of the two integers, whilst the B is the smallest integer. So over here we have 10 and 45. Therefore, our 45 is going to be A, while 10 is going to be B. Now, what do we need our A and B for? I'm going to take you back to another algorithm which exists mathematically, which is called the division algorithm. The division algorithm states that for any two integers A and B, where B is greater than 0, there exist two other unique integers, Q, which is the quotient, and R, which is the remainder, such that A is equal to BQ plus R, where 0 is less than or equal to R and R is less than B. That is the division algorithm. So what's the division algorithm talking about? The division algorithm is telling us that supposing we have two integers, A and B, where B is greater than 0, meaning B ranges from 1, 2, 3, all the way to positive infinity. It's telling us that there exist two other unique integers, Q and R, where Q is the quotient and R is the remainder, such that A must surely be equal to BQ plus R. That is, A is going to be equal to B multiplied by the quotient with a remainder R. That's A is equal to BQ plus R. But 0 must be less than or equal to R, meaning R has to be greater than 0 or equal to 0. R cannot be less than 0. The remainder can never ever be less than 0. It has to either be equal to 0 or greater than 0. And the remainder also has to be less than B, meaning B should be greater than R. The remainder can never ever be greater than B. So that is the division algorithm. So enough of this topic. Now we are going to transfer this knowledge we have from the division algorithm back to the Euclidean algorithm. From division algorithm, we have found out that A is equal to BQ plus R, right? So now let's transition into Euclidean algorithm. Remember, I earlier said we should make our B 10 and we should make our A 45. So that means that 45 is equal to 10Q plus R according to division algorithm. So 45 is equal to 10Q plus R, where Q is our quotient and R is our remainder. So the question we are going to ask ourselves is, how many times can 10 go in 45? Now, the number of times 10 can be found in 45 is going to be our Q, which is the quotient. And obviously from this equation, 10 can go into 45 4 times. You can find 4 10s in 45. then can go into 45 4 times. Therefore our q, which is the quotient, is 4. So that's that. Now how can we find our r, which is the remainder? Recall that if 10 goes into 45 4 times, we are going to have a remainder of 5. I come again. If 10 goes into 45 4 times, we are going to have a remainder of 5. Therefore our r, which is the remainder, is equal to 5, while our q, which is the quotient, is equal to 4. So 45 is equal to 10q plus r can now be rewritten as 45 is equal to 10 times 4 plus 5, where q is 4 and r is 5. Now that is the first step. Now we are now going to perform another long division, this time between our b and our remainder. What we are going to do now is rewrite this equation. Now we are going to divide our b by the remainder. We are going to be dividing our b by the remainder. That is, now we are going to be having 10 is equal to 5q plus r. Our b from the previous equation is now our a, while our r, which is the remainder, is now our b. Hence the reason why we had 10 is equal to 5q plus r. I don't know if I'm making sense. Our b from the previous equation became our a, then our r from the previous equation became our b, and that's how it is going to keep on moving repeatedly until we find our GCD. So we have 10 is equal to 5q plus r. So how can we find our q and how can we find our r? We are still going to perform the same thing. We are going to ask ourselves, how many times can we find 5 in 10? And obviously we can find 5 in 10 2 times, meaning our q is 2. I come again. Since we can find 5 in 10 2 times, it means that our quotient is equal to 2. So we have found our q. How then can we find our r? Since once we find 5 in 10 2 times, there is no remainder. Once we find 5 in 10 2 times, there is no remainder. It means our r is going to be equal to 0. It means our r is going to be equal to 0. Remember earlier I said our r cannot be less than 0, but it can be equal to 0 and it can be greater than 0. So in this instance our r is equal to 0. So now since we found out that the remainder is equal to 0, we are going to take a break. Now we've solved up to the part where our remainder is equal to 0. Then what is our greatest common divisor? Is the greatest common divisor of 10 and 45 equal to 0? No. The greatest common divisor can never ever be equal to 0. The greatest common divisor is usually the last remainder which is greater than 0. The last remainder which is greater than 0. Therefore, the GCD, the greatest common divisor of 10 and 45, excuse me, is equal to 5. Let's take another example. Find the GCD of 1785 and 546. Now looking at this question, you may be scared as at how are we going to do this with these two hefty numbers. Take a chill. Firstly, let's identify our a and our b. Obviously a is the greatest of the two integers, that is the biggest integers between the two integers, while the b is the smallest one. So here our a is 1785 while our b is equal to 546. Division algorithm states that a is equal to bq plus r. Therefore 1785 is equal to 546q plus r. Now how can we go about to find our q and our r? We're going to ask ourselves, how many times can we find 546 in 1785? If you use your calculator, you will find out that we can find 546 3 times in 1785. We are going to find 546 3 times in 1785. And when we find 546 3 times in 1785, what is the remainder going to be? The remainder is going to be equal to 147. I'm going to be calling digits out already because I've already solved the question prior to shooting this video, so you can confirm with your calculator or move along with the flow. So our q therefore is equal to 3 while our remainder is equal to 147. As said in the previous example, our b from this question now, from this first equation, is going to become our a, while our r is going to become our new b. I come again. Our b from this equation is going to become our new a, while our remainder is going to become our new b. So we are going to have a is equal to bq plus r, that is 546, which was our b, is now equal to 147q plus r. 147 remember was our former remainder. Sorry for that. So now we have 546 is equal to 147q plus r. We are going to ask ourselves again, how many times can we find 147 in 546? We are going to find 147 3 times in 546. Therefore, our q, which is the quotient, is equal to 3. But when we find 147 3 times in 546, what is the remainder going to be? Obviously, we are going to have a remainder of 105. Therefore, our q is 3 and our r is 105. Again, our b from this equation is going to become our new a, while our remainder from this equation is going to become our new b. So we are going to have 147 is equal to 105q plus r. I hope you get the concept. 147 was our former b, then it became our a, while 105 was our former remainder, then it became our b. So we have 147 is equal to 105q plus r. Now we're going to ask ourselves, how many 105 can we find in 147? Obviously, we can only find one 105 in 147. Therefore, our quotient is equal to 1. But when we find 105 once in 147, what is the remainder going to be? The remainder is going to be equal to 42. Therefore, our remainder is equal to 42, whilst our quotient is equal to 1. Now, our b from this equation becomes our new a, and our remainder 42 becomes our new b. By stating that, it means we are going to have 105 is equal to 42q plus r. Now, how many times can we find 42 in 105? We can only find 42 2 times in 105. So we are going to have 105 is equal to 42 times 2 plus r. But when we find 42 2 times in 105, what is going to be our remainder? Our remainder is going to be equal to 21. So now our remainder is equal to 21, whilst our quotient is equal to 2. Can you tell me what our new equation is going to be, or what the next equation is going to be? Remember, our b from this equation will become our new a, so that is 42 is going to be equal to 21q plus r. 21 was our former remainder and it became our new b. So now we're left with 42 is equal to 21q plus r. And now we're going to ask ourselves, how many times can 21 go in 42, or how many times can we find 21 in 42? Obviously, we can find 21 in 42 2 times. Therefore, our q is 2. But when we find 21 in 42 2 times, what is the remainder going to be? Obviously, the remainder is going to be equal to 0, because 21 times 2 is equal to 42. Therefore, our q is 2 and our remainder is 0. Once we get to the point where our remainder is 0, we are going to match our break. So now, since we found out that the remainder is equal to 0 finally, what is the greatest common divisor of 1785 and 546? The GCD of these two numbers is equal to 21, because 21 is the last remainder which is greater than 0. Therefore, the GCD of 1785 and 546 is equal to 21. Now, how can we apply this thing we just found? What does it mean? What is the meaning of the GCD of 1785 and 546 is equal to 21? It means that 21 is the biggest number that can divide both 1785 and 546. I come again. It means that 21 is the biggest and the greatest number in all numbers that can divide both 1785 and 546. Thanks for watching today's video. I hope you understood all that was taught. I hope you understood all the concepts. I hope everything was clear. and understandable. Kindly reach out to me through the comment section in case you have any questions whatsoever. You can suggest new topics or new videos which you would like to see me create, and I'll surely try my best. Thanks for watching once again. I appreciate you. God bless you.